Anytime. There we go. All right. Let's start off today with this warm-up. The function f is defined by f of x is equal to negative 2x cubed minus 2x squared minus 4x. And the point, negative 1 comma 4, is on the graph of f, saying that if you plugged in negative 1 for x, you'll get 4 out for your value of y, or your output value on this function. If g of x is the inverse of f, what is the value of the derivative of g evaluated at 4? Okay, so g of x is the inverse of f of x. So that means that if I was trying to calculate the derivative of g of x, I know a shortcut for that, right? I know a shortcut for that. And the shortcut for that is going to be 1 over the derivative of the original function, but evaluated where g of x is, right? Now remember, if g of x is the inverse of f of x, that means it spits the reverse of the inputs and outputs, right? It switches them. So what does that mean for us? Well, they give us a point, and this point right here is negative 1 comma 4. That means, right? That means if you remember, right? F of negative 1 is going to give me an output of 4, right? This is like a side note, right? That's what that point represents. Basically, if you plug in negative 1 for x, you get positive 4 as your output. Well, if g of x is your inverse function, then that means g of 4, does anybody remember? What would that give you instead? What does the inverse function do with your inputs and outputs? What should g of 4 be? Negative 1. That's right, Monica. Brian, thank you. Max as well. Thank you, guys. Good, good. You remembered, right? That's all the inverse function does, right? It just takes your output and spits back out what your input should have been. JID? Max, I don't know what you're trying to say there. Unless that's an acronym that I don't know. Which could be the case because I am pretty old now. I'm assuming that's an acronym, or you just typed out JID for the heck of it. All right, let's keep going. So, can you guys go ahead and tell me then? What is g prime of 4 going to equal to? And go ahead and start working that out. I'm looking at your Pear Deck answers right now as I speak. Hope you guys can take a look and go through it. Juliet, maybe, bruh. You can try it now, Juliet. I have the shortcut for you there. See if you can figure out how to plug that stuff into there so you can get your answer for that one, okay? Let's see it go. Let's see you go. Okay. Monica, beautiful, beautiful work. I see that. Let's take a look and keep going here. Brian, same to you. Looking good, looking good. I like the notation you got there. Gracie, that's a great start. You do need the derivative of f, so you are in there. It's good. Joe's got it going. He's starting on there. Oscar's got the answer. Looks good, Oscar. Looks good. David, starting off, same thing. Good job with finding the derivative of f of x. That's a great start. Ava's doing the derivative. She's typing it out. That's beautiful. Calvin's writing out the necessary means for this one. That's good. Keep going. And then there's about 12 of you who haven't responded yet, but I appreciate the 12 of you that have clicked into here, at least clicked on the link. So there's a total of 23 students who clicked into here, and I have 33 students in this class. Why do I always have like 10 kids missing? You guys need the link? Did you guys come in a little late maybe? Or you're just having trouble with your internet? Either way, I'll put the link back in the chat if you guys could. Join in there and join in on this warm-up right here. I'm sharing my screen, right? Yes, I am. Okay. So, like I said, I gave that hint, right? Is negative 1 squared 1? Yes. Yes. It all depends on your parentheses and your symbols of inclusion. Just on a side note, if you had x squared, right, and you were plugging in negative 1 squared, yes, that is equal to 1. If you have negative x squared and you plug in negative 1, you do not apply the negative first, you apply the squared first, which will become negative parentheses 1, which will then become negative 1. So you got to be careful with your plugging in of numbers and your negative signs inside and outside. So just keep that in mind. Okay. All right. Let's see here. How are we doing? We get any more people to click on that link? I promise you, it's not a virus link. It's just a link for your Pear Deck, guys. It's just a link for your Pear Deck. 24 kids. Okay, 24 out of 34. Why are there always 10 less than the number of students in this class who are clicking on this link? What's going on? Nah, it could just be coincidence, but you know, who am I missing? Let's see, we got names though. We got people already in here. Oh, I see Emily. What the heck? My lights just turned off. I turned this on too. All right, there we go. Okay. Calvin's in there. Raheesh. Emily. Jeffrey's in there. Max, I see you starting to write things up. Brian N., I see you in there as well. And then the other people who clicked in here was Diana, Eric, Shirley, Angela, Cheyenne, Julia, Brandon, Frankie, Leslie, and Fatima. Who am I missing? Who am I missing? I don't see Ilias. Are you having trouble clicking in here, or it's not working? Oh, Kimberly clicked in. This number just keeps growing. There's 35 students in here. I'm missing Jackie. But who am I missing who's not clicking in on this link? Oh, well, we'll go through the list later. All right, so back to the problem at hand. All right, hopefully you've clicked on it. Let's take a look here. So things that you're going to need. You're going to need f prime, meaning you're going to have to take the derivative of f, right? So let's do that real quick. F prime of x is going to be equal to the derivative of this up here, which is going to be negative 6x squared minus 4x minus 4, right? So that's our f prime. We're going to need that because this right here is going to be the derivative of the inverse function evaluated at 4 is simply just 1 over the derivative of f evaluated at g of 4. So I have f prime of x now. I can plug this in, but I need to see what I need to plug into that, right? I need to plug into this derivative function what g of 4 is. Well, I know what g of 4 is. G of 4 is equal to negative 1. So that means all I got to do here then is find out what f prime of negative 1 is, right? That's what I'm going to be replacing this g of 4 with. I'm going to be replacing it with a negative 1, okay? So I have over here, this is going to come out to be negative 6 times negative 1 squared minus 4 times negative 1 minus 4. So let's simplify this out. F prime of negative 1 is equal to negative 1 squared is positive 1 times negative 6, still negative 6. Negative 4 times negative 1 is plus 4 minus 4. This is going to be just a negative 6. So that means that this whole thing, this right here, this f prime of g of 4, is going to be replaced with a negative 6. So what's my answer for the derivative of the inverse function evaluated at 4? It's just going to be equal to 1 over negative 6, or in other words, negative 1/6. And that's it. That's how you find the derivative of an inverse function. That's all you got to do. And if you're not even evaluating it at a point, then you could just leave it as 1 over f prime evaluated at g of x. And that would be it. That would be your answer. And I got to say, a lot of students did a pretty good job on this one. Let me go ahead and share some of the answers that I was calling out earlier. And I just wanted to, oh no, did I close that box? No, you're over here. For some reason, I moved you. There we go. Let's go ahead and share a couple of these answers here. I just want you guys to see it. Beautifully done. Whoops. Nope. Go back. Beautifully done. Sorry. Oh no. Hopefully that didn't mess up your stuff. But there we go. So one student got the answer right there. Showed the derivative. Showed that the inverse of. Well, be careful with this one. Be careful with this notation. Don't write g prime of 4 is equal to 1. Write g of 4 is equal to negative 1. You gotta be careful with that. But yeah, that's it right here. G of 4 equals to -1, and that goes into the derivative function, and the derivative function is probably done somewhere else, and you got -6, hopefully. But yeah, that's the idea behind finding these derivatives. Okay. Oh wait, -1/6. It's technically 1 over -6, but you know, when you simplify the fraction, it's -1/6 if you want to write the negative out in front. That's how it works out. Now, I think we briefly talked about this last time, but I think you guys might have forgotten, or at least I don't know if we got a good amount of practice on this. So I was looking over your homework, and a lot of them don't give you the point that it's on, meaning they don't tell you that f of x is, they don't tell you what the input value is or the output. They only tell you, they're only going to get, they're only going to ask you the inverse of this output value, but they don't tell you what the input value is. You know what I mean? Like, they don't give you this point. They don't tell you like, oh, f of -1 is equal to 4, therefore the inverse function should go backwards. They instead just ask you the backwards part, and they don't tell you what to initially start off with. And I think that caused up some issues for some students who came into my office hours before we went on break. So I wanted to go over that one more time, right? One more time. So hopefully you guys got this warm-up down. Let's go ahead and move on to that example that I'm talking about. It was on the homework. Let me show you the homework real quick. This is the homework, by the way. It was part 1 of the homework for 3.4, which is just all inverse stuffs, right? And if you look right here, just starting off right off at number 7, right? It does not tell you the point where f of what is equal to 2. So therefore, I don't know what g of 2 is equal to. It doesn't. I can't go backwards on this one. So let's take a look at this problem. I'm going to screenshot this, and let's start off with this one. And there's a couple of these that will not tell you what the input and output value is. So you see right here, this one they tell you, hey, g is the inverse function, or g is the original function, and f and g are inverses of each other. They don't say which one's the inverse of which. They just say that they're inverses of each other. And they tell you that g of 2 is equal to 5, right? That means f of 5 should be equal to 2. You see what I mean? So they give you this input-output relationship between the two functions, whereas our warm-up did as well. Our warm-up did it in the form of a point, this -1 and 4, right? F of -1 goes to 4, g of 4 goes to -1. That's all well and good, but if you look at number 7 right here, they only tell you that you're trying to find the inverse, right? The derivative of the inverse evaluated at 2, but they don't tell me what was the original x value that spit out to. Does that make sense? Now I don't know what g of 2 is going to go backwards to. So how do we approach this problem? How do I find that out? That's what I wanted to cover today before we move on to the next topic. Okay, so if you guys could take a look. If you guys want to copy this down, this is a homework problem, so that way it's one homework problem done. If you've already done this problem, that's awesome. That means that you were able to do it from that one example I did. But if not, don't worry about it. Let's just cover this one together. Okay, so you can copy this down. This will go towards your homework. So let's take a look here. Using the method above, we don't have that method above. All right, so find g prime of 2, where g is the inverse function of f of x equaling to x to the 5th minus x cubed plus 2x. Okay? Well, I don't know. The problem is, right, I know that g prime of x is equal to 1 over f prime of g of x, right? My only issue right now is I don't know what g of 2 is equal to. They don't give me that information. But they do tell me that f of x is equal to this quintic, I believe. It's when you have x to the 5th, right? So g of 2, I don't know what it is, but I could figure this out. And usually when we do these types of problems, it will be on a calculator portion. So this is where you should pop out your graphing calculator. Either if you're going to be using Desmos, use Desmos. If you're going to be using the TI calculator, use the TI calculator. But probably practice more with the TI, just because that's what's going to be usually is allowed on the AP exam. They don't usually allow the Desmos calculator, but it's easier on the Desmos calculator. So let's go ahead and take a look here. So this is what's basically is being said here. F of what value is going to give me 2? That way, g of 2 is going to give me that said value, right? So I need to figure out, when does this thing equal to 2? When does this f of x function equal to 2? That's what this is stating. That's what this inverse function is stating. So what I'm going to do is I'm going to graph f of x, and I'm going to see where does it equal to 2. And there's a couple ways to do this. Right? So if you don't know how to graph on your TI calculator, here's how you start off, right? Start off by pressing the y equals button. Do you guys see that? Y equals, that's right here. That's where you get to type in your function where you want to graph, okay? I'm going to go ahead and graph this out. This is going to be x to the 5th minus x to the 3rd plus 2x. Whoops, that's not how I want it. Let me go ahead and delete that. Don't press clear, by the way. If you press clear, it clears out the whole calculator. So I'm going to go ahead and delete those parts here, and then go ahead and put plus 2x. Go ahead and hit graph, see what this graph looks like. And looks almost like a cubic, right? Looks almost like a cubic. So you guys can kind of see, where does this graph equal to 2? Do you guys see it? The graph is equal to 2 right around there. Right? It looks like it's when x is equal to 1. But just to be sure, you could do it algebraically, and you can kind of see, oh, 1 to the 5th minus 1 to the 3rd is 0 plus 2 times 1. That is 2. That is going to be the right answer. But let's say we were not able to do that, just by looking at those numbers, and you have to do it on your calculator. One thing you can do is go back to your plot on your graph and let the equation the second equation be equal to the number that you want it to equal. In this particular case, I want it to equal to 2, right? That's what I'm asking for. What is the value I plug in to get an output of 2? So I put in 2 right there, and I graph it, and it graphs this line that goes across that 2. I need to figure out where that point is where they cross. The way we do this is, on your calculator, you have this function that calculates where 2 graphs can intersect. So we hit second and trace, and I'm not looking for the 0. I'm not looking for the minimum or the maximum. I'm looking for where the 2 graphs intersect. So I go down to that option, intersect, press enter, and it'll ask me, where is the first curve? So it follows along the first curve. You see how it travels along here? I want to get it as close as I can to that point of intersection, which is right about, no, that's too far, right about there. It's okay if it's not perfect. It has to be just close enough to it. The second curve now is following along, if you can see here on the y equals 2 graph. I'm going to go as close as I can on here as well. Press enter, and my guess is, pretty close to that as well. So press enter one more time on that guess, and it tells me it intersects at 1 for my x value and 2 for my y value. That means that for f of x equaling this guy right here, this function that I have written out, they're telling me that f of 1 is equal to 2. And you can see that by looking at the point 1, 2. It's a point that is lying on that graph. Now, what does that mean for us? Well, now that I know that f of 1 is equal to 2, what does that tell me about g of 2 then? If g is the inverse function, g of 2 is going to be equal to 1. G of 2 is going to be equal to 1. And why is that such a big deal? Why do I need to know that g of 2 is equal to 1? That helps me to find my derivative of the inverse, right? Because that's telling me that g prime of 2 is simply going to be equal to 1 over the derivative of f evaluated at g of 2. But lucky for us, we just found out that g of 2 is equal to 1. So that's going to tell me that g prime of 2 is equal to 1 over f prime evaluated at 1. Right? F prime evaluated at 1. Which means then f prime is something you also have to find, which is the derivative of that, which is going to be 5 times x to the 4th minus 3 times x to the 2nd plus 2. And we just simply plug that in 1 and see what we get here. We get 5 times 1 to the 4th minus 3 times 1 squared plus 2. So 5 minus 3 is going to give me a 2 plus 2, which is 4. This is going to be equal to 1 over 4, and that's my answer. So if they don't give you the point and they don't tell you what the input and the output value relationships are, you can find it. And what I'm going to have you do is find it using your graphing calculator. Okay? You plug in the function, your original function, not the inverse. Plug in the original function, and then do it that way. Brian is asking, is there a way that you can find it algebraically? And yes, there are ways that you can do it, but that's what I mean. When we start getting to things that are higher than x squared, you're starting to solve for higher degree polynomials, and it gets kind of difficult. It gets kind of difficult. Like this one, I don't think there's an easy way. There is a way to do it algebraically, but it isn't one that's convenient. Once you get to x cubes and higher, there's no real easy algebraic way of doing it, and it's just not worth going into doing it algebraically, I should say. But there are ways. There are ways. It's just something that's not going to be covered, and it's not that important to be covered in calculus. I know that sounds weird, but like I said, the calculus stuff is going to be easy. It's the algebra stuff that's going to be a little difficult. And we don't actually have an easy algebraic way of solving powers higher than, I'd say, x cubed. Right? Even x cubed, there's a, you know how you guys have a quadratic equation for quadratic formulas? You guys know that thing that you have to memorize, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a? That's supposed to be an easy way of solving quadratics. There's an equation that's for cubics as well, but it's not as easy to remember. And I don't even think there is one after x cubed. I don't think they have one for x to the fifth. So at that point, we just end up graphing it, and it's just easier to solve graphically to see where does this thing equal to 2. Hopefully that answers your question, Brian. But yeah, that's how I would approach this one. And again, if you're not comfortable using the TI calculator to get this feature, like, go back and watch me explain it. I'll put this video back up and follow the steps through it. It is something that you should practice. But if you're looking to just do this for your homework, just because like you're crunched on time, go to Desmos and graph it. It's so much easier on Desmos. I feel like an ad for Desmos, but you know, I'm just so like, I don't know. I'm just so appreciative of like their work. Look how easy this is. So you get the equation, right? What's the equation? X to the fifth minus x to the third plus 2x, right? Boom, right? There's your graph, okay? Now, like I said, I'm trying to look out to where it's y is equal to 2. Where is this original function equal to 2? And they graph it for you. Now, instead of having to go through and hit second, calculate, and tell it, I want to see where it intersects, whenever you graph more than one graph on Desmos, they automatically plot the point where they cross. This is just look at it, just like there, right? You can graph anything you want. You graph 2 different graphs, and it automatically shows you where the 2 graphs cross. Like you can click on it, and it will mark it for you. Like I can say instead of y equaling to 2, let's say they didn't ask me for g of 2, they instead asked me for like g of 4, right? Or let's go with something crazier, g of 100. I pick 100. Boom, that's that one right there. I would have to on my TI calculator, I would have to zoom out to where I'm have the y value at around 100, and then calculate the intersection up there. Whereas again, this one right here, I could just click where they cross. Boom, I have where they cross. My x value is 2.569, and my y value is 100. A quick word from our sponsors, doesn't, you know, for as a nice site as Desmos is, like all the stuff they do, all the things that you can do on there, it's crazy to me. There's no ads on there. They don't get money from advertisements, you know? They don't get money from people from using their site either. They don't have a subscription fee. They don't have a premium, which I think might happen at some point if it gets even more popular. So I don't know how I feel about that, but they haven't done it so far. It's been a couple years so far since this thing has been out, and nothing like that. I'm not addicted, Sam. I'm just appreciative. Is that the right word I'm looking for? Appreciative? I just appreciate their work. That sounds better. English is weird. All right, so how do you guys feel? Any questions on calculating the derivative of an inverse function, right? First stage is to know. Look, guys, I don't have a problem. I can work with other calculators. Look, you saw me work with the TI calculator. It's fine. It's fine. All right, so as I was saying, how do you guys feel about this? I'm gonna put it onto the Pear Deck right now. If you guys could move your dot, tell me, how do you feel about finding the derivative of an inverse function? Does this make sense, or are you like completely lost, or are you feeling a little bit better about how to do these types of problems? Okay. Be honest with me. Again, if you need a little extra help, you can always stop by my office hours. I do have office hours today, right? And we can do a couple more of these problems. Okay. I will assign Delta Math today too, because I think I'm going to be finishing up Unit 3 today. And you guys said that you like watching the videos on Delta Math, right? I can open those up so then you guys can watch the videos on there and they explain it. I think the same way as me, but I think for some reason you guys like it on there, right? That's what you guys told me, that you guys enjoy the videos on Delta Math. So I'll make sure that that's unlocked for you guys so you guys can watch the videos and, you know, just in case you need that extra explanation. All right. That's it, guys, for derivatives of these inverse functions. Hopefully you guys get this down, and if not, you know, you have this written down somewhere. And that's all it is. It's just a shortcut, right? Just like the low-d high minus high-d low over low-low for the quotient rule, just like product rule, just like the derivative of trig functions. I'm not asking you to do them from scratch. I'm not asking you to do the limit definition of them for all of these. We learn these shortcuts so that we can do these ones if we ever come across these types of problems. Right? If they ever ask you, hey, what's the derivative of the inverse evaluated at this point? Bam, I got this right here. But yeah, so take a time, put in the effort to try to get to know this, try to learn this, try to get this down. Okay. And I think I showed you how this thing is derived. Like I said, I was always terrible at memorizing things, so I would like just derive things during the test. I didn't derive this one. I would always, as I think was it Brian that asked, is there a way to do this algebraically? I would try to algebraically find the inverse of this, which I found out is almost impossible to do. So I'm telling you, this is the easier way of doing it right here, if you are looking for inverses of functions. All right, that's enough of that for the inverses of functions. Let's go ahead and move on to our last couple of topics here, okay? Oh, wait, no, I lied. I got to do a table real quick. So one more example of this before we go on. Before we can go on, let's go ahead and take a look here. So if you guys could, take a look at finding these derivatives using tables. Good old tables. Good old tables. The table below gives selected values for the differentiable and increasing function f and its derivative. If g of x is equal to the inverse of f of x, what is the value of g prime evaluated at -1? Whew. So this one's looks different because they don't give you the function, but I'm hoping you understand that as long as g is the inverse of f, it still follows the same rule. Meaning, if I'm looking for g prime of x, that's just going to equal to 1 over f prime evaluated at g of x. Okay? Well, what does that necessarily mean? That means that if I was looking for g prime of 1, which is what they're asking for, if I'm plugging in -1, I just need to find out f prime of g of -1. Well, that leads me to my my next part then. What is g of -1? What is that equal to? Remember, if f of x takes an x value and gives you an output, so for example, if you plugged in 8 into f of x, you'll get 5. If you plug in 6, you'll get 4. Here's the thing. If you take -4, you plug in -4 into f of x, you'll get -1. Hint, hint. Look, look. Do you guys see that? It's not this -1 that you're looking at, because this -1 is an input and you get an output of 1. That's not what I want. I want the output as -1, and that's this guy right here. What should the input be if I want the output to be -1? Can you guys see what I'm talking about? G of -1 is not equal to 1, right? F of -1 is equal to 1. G of -1, on the other hand, though, since it's the inverse function, it goes in the other direction, and G of -1 is actually going to be -4. Did I lose anybody there? Are you guys okay? Does that make sense? I'm hoping you guys can see that based off this table. This is where they try to trick you, right here and right here. G of -1, right, is where they're trying to switch up on you. You see here, I care about the output. I don't care about the input. That's the difference between the two. So G of -1, can you explain why you did that again? Yes. So here's the deal, right? F of x takes numbers from the x column and gives me all these output values. So this is like my input. This is my output, right? What my g function does, since g of x is the inverse of f of x, right? It's going to take all these numbers and switch them around. So if I have an inverse function, it'll switch these columns around. So this will be -1, 1, 2, 4, and 5. And then the output values for the inverse functions will be the same ones, but they swap with each other. So it'll be this -4, -1, 3, 6, and 8. You see what the g of x and the f of x are inverses, so the input and the output switch with each other. You see that? Yeah. So when they're looking for g of -1, I'm telling you, they're going to try to do this. They're going to give you that -1. They're going to try to trick you, right? They're going to try to trick you and say, hey, -1, you want to put 1, don't you? But that's for f of x. That's for f of x. That's for the f function. The g is the inverse of that. You need to be able to spot that, hey, the g function switches them with each other. Okay? So g of -1 is actually -4. That's this guy right there. And you could, and some people are able to see it just from here. They're able to switch it with their minds and see it like that. But what might actually help is if you write down your inverse function on another table below it and kind of switch those values around. It makes it a little bit easier to deal with. Okay? Does that make it a little bit better? Does that make a little bit more sense? Hopefully it does. Hopefully. Oh, give me a second here. All right. So hopefully that helps you out. Okay. Now that you know that g of -1 is equal to -4, everything else follows back into place, right? I can replace this guy right here with a -4. So g prime of -1 is equal to 1 over f prime evaluated at -4. Like that. Now I can just use this table like normal, can't I? So g prime of -1 is equal to 1 over f prime of -4. Well, f prime of -4 is equal to -2. And that's your answer. Doing these graphs on from the tables are actually a little bit easier, but they're different from dealing with those equations because you don't actually have to physically take a derivative. They give you the table that they spit out those values for you. So that's that one right there in a nutshell. Hopefully that makes a little bit more sense. So you feel a little bit better now, hopefully, with the whole idea of these inverses and their derivatives. Okay? Yeah, hopefully that feels a little bit better. And again, if not, let me know. You'll have a bunch of resources there. You have a bunch of practice problems to do. And if you're still not getting it or you don't know how to start it, you got to try something. Don't just look at it and just be like, I don't know where to start. You can either come ask me for help, ask someone else for help, watch a video on these. Like there's so many people who are explaining these things. You have many resources. So don't freeze up. Okay, just go ahead and try different things to see if you can figure it out. All right. Anyways, that's that one in a nutshell. Let's go on to the next topic. This is the last two topics. Yeah, the last two topics on this chapter. They're just different derivatives that I wanted to talk to you about here. So let's take a look here. So this is going to be the derivatives of e to the x and ln of x. Derivatives of e to the x and ln of x. These are the most memest, or I'm sorry, e to the x is like the most memest like derivative that you'll look at. You ready for this? If I'm going to be taking the derivative with respect to x of e to the x, all right? You ready for this? You got to have to memorize this one, though. You got to know this one just like you know your tangent, your cosine, sine. You got to memorize these ones down. You ready for the derivative of e to the x? Derivative of e to the x is e to the x. Yeah, I know. What? So you're gonna have to memorize that one just like you memorize sine, cosine, tangent, those hard ones, right? This one's just as hard. You got to know that when you take the derivative of e to the x function, it's e to the x. Yeah, it's a lot. It's a lot going on there. And I don't know how they can memorize that, but oof, it's so much going on. But it's a really interesting number. You guys know how pi is like that special relationship between the diameter and the circle, right? You might not know that, but you might know that pi is 3.14. But that's what pi is. It's the ratio between the circumference and the diameter of the circle. And it's a weird thing that happens. No matter how big of a circle, how big a diameter it is, it's always a ratio of pi. And that's what makes pi special. E, on the other hand, is special in a lot of different ways. Like E is a number that comes up from the development of the limit as x approaches, I think, God, I forgot the definition of E already. It's like, I think x approaches like infinity or something like that. No, it approaches 0. Hold up, I got this. Limit definition of E. Right, let's see here. Yeah, it's something along the lines of like the limit as n approaches infinity of 1 plus x over n to the nth power. It's like some crazy looking thing. And we get this number E from it. Well, what's even crazier is the way the graph accelerates, right? It looks like this exponential graph, something like that, right? And what's weird about this is that as it climbs, right, the slope down here is very, very close to 0, right? So if I was to graph its derivative, so if this f of x right here is equal to e to the x, and I were to graph its derivative, right? So the slope down here is almost 0, which is down here. And then as it gets closer and closer, the slope starts to increase, right? So it's getting more and more positive. So it's getting more and more steep. And it just so happens that at every single x point, the derivative is equal to the value of the point that it's at. And this only happens with the base e. It doesn't happen with any other base. It doesn't happen with base 2, base 5, base... Like if I had f prime of x here is just going to be equal to e to the x again. If I had, for example, f of x was equal to 2 to the x, that's not the case. If I took the derivative of this, it would not equal to 2 to the x. It would equal to something crazier, right? This only works for e to the x. And there's like a whole like limit definition that proves it. There's a whole actually, I don't know if I want to show you it. No. It is an interesting proof, but I don't think we have the time for it. But yeah, that's the idea. If you look at it, it kind of makes sense because as it approaches it. But then it doesn't work for all exponential functions. It doesn't work for 2 to the x or 5 to the x. It works only for e to the x, and it's special in that little sense right there. But yeah, let's actually do a problem here, right? I know some of you guys are like, how do you actually do this problem if just the derivative of e to the x is just e to the x? Well, remember we learned chain rule in this chapter, and e to the x can have the chain rule applied to it. So let's actually do a couple problems, and then I'll show you how this works out. So let's actually work one problem out here. Let's ask here, I was asked to find, right, dy dx, right, where y is equal to e to the 2x, okay? E to the 2x. I don't know if you guys can see this or not, but e to the 2x is actually a composite function. It's made up of two functions, and they're not multiplying with each other. It's not the product rule. It's not e times 2x. It's e to the 2x, right? Meaning I have an inside function, right? And my inside function is 2x, and my outside function is e to that 2x. When I take the derivative of this with respect to x, right? The derivative of 2x is just 2. The derivative of e to that stuff is still e to that stuff. That doesn't change. So you ready for this? What is dy dx going to be equal to then for this equation? Well, the derivative of the inside, which is 2, times the derivative of the outside, which is e to the 2x. So whenever you're dealing with an e function and you have to take the derivative of it, basically you just have to take the derivative of what's inside and just multiply with the e function itself. Because this right here, the derivative of the outside, since it's the e function, it never changes. It stays the same. No matter what. No matter what. I think it's kind of neat, but it's also kind of, it's a very simple idea. I'm hoping you guys can see that. Right? Let's do one that's a little bit more difficult. Let's do an e function that is multiplying with something. So let's see here. Let's say I have here, I was asked to find, right, y prime for y equaling to x squared e to the 2x. So if I was asked to find y prime for x squared e to the 2x, I'm hoping that you can see what do you need to do? Which rule do you need to apply for this right here? What are the functions doing to each other? X squared e to the 2x. And a lot of people are already typing out. It's the product rule, right? Yeah, it's the product rule. And Brian's going in there above and beyond. Not only do you have to product rule this, but when you take the derivative of that e to the 2x, you're going to need to chain rule that, right? Hopefully you guys can see that x squared with e to the 2x next to it. When you write stuff like this, you're multiplying them together, meaning you need to product rule this if you're going to take the derivative of that. A lot of students have trouble seeing that when there's no parentheses around. But I don't know why, but you guys should have seen this throughout your years in doing all these math math problems. So if I was taking the derivative of this guy, I would use the product rule, right? The product rule here. So this is going to be derivative of the first, which is 2x times the second, e to the 2x, plus the derivative of the second, e to the 2x, times the first. And then that's it. I would just leave it like that. I wouldn't go any further or do anything else. But if I really wanted to show my work, I would say like, oh, if this is f of x and this is g of x, then this is going to be f prime times g plus g prime times f, if you really wanted to show your work. Which, by the way, I graded your tests. I don't know if I told you guys this or not. I haven't calculated the curve yet because that takes a little bit of effort. Oh, shoot. I forgot to chain rule this guy. That should be bad, knock me bad. I should got to chain rule this. Chain rule this guy. Well, we had the work. We had the, no way. Knock me. I'm sorry. E to the 2x. There we go. Does that fix it? Oh, Monica caught it. Wait, don't we have to find that? And then Max as well. All right. So we got that. Oh, Max, don't call me that. I'm not a noob. I just haven't woken up yet. Technically asleep right now. All right, so let's go ahead. Does that look right now? I hope that looks right. Anyways, don't wake up the beast. All right, so yeah, product rule and then chain rule. We even talked about that. That's good. What was I talking about? I forgot what I was talking about after that. I'm gonna make a statement on something. Oh yeah, I graded your test. Oh yeah, how to simplify. You don't have to simplify, but if you really wanted to, you can. On your test, a lot of people who wrote it like this got full credit. We'll talk about that in a second. But yeah, if you want to simplify it, I would write this out as 2x e to the 2x plus 2e. Man, that is... there we go. So this would be 2x squared e to the 2x. There you go. If you really wanted to simplify it, right, that's the traditional way. You write the variable first and then the e function at the end of it. It doesn't really matter though when you do it on, like, let's say Delta Math. I think Delta Math, unless they ask you to simplify, they should take it as the first answer when you first do it. And as I was saying, I was grading your tests, and this is the interesting part. So I had to talk about it with my fourth grade. I don't know if I talked about it with you guys, but there was like, I'd say like maybe 2 or 3 students who you can clearly tell used some type of software to do the derivatives for them because they got like weird and ugly. And I was like, man, I told you guys, don't use those programs. Like, they suck. Sometimes they do it just fine. Sometimes it works out just great. But when you throw in like a tangent or you throw in like an E function, they go off the rails, especially when you're doing like a product rule. They do like these weird steps. And then like, it just messes you up. Okay, so I'm just letting you know, like if you just know that the product rule is derivative of the first times the second plus derivative of the second times the first, and you just write this down, this isn't that hard to get. I think this is easier than using those software programs. They're so weird. I don't know what it is. Just become your own calculator. Yeah, I'm telling you, it's easier than doing those things. I'm totally for. I don't know if you guys can tell, like, since I'm so for Desmos, I'm so for like the TI calculator, I'm so for technology working these problems out for you, right? They're awesome when they work correctly. But I'm just telling you right now, a lot of the more difficult problems, those calculators kind of just like, they poop the bed when they try to get to the answers that you need. And I saw them when I was grading your test. I was just like, yeah. So I tried to give you some points because it looked like you were, I don't know, I was just being nice. I was trying to give some points, but I didn't want to give you a 0 for it. So yeah, just keep that in mind when you're working out these problems, right? You're better off trying to do it on your own. And in fact, if I saw that you just didn't know what the derivative was, but you knew the rule, I think that was one of the cases on this recent test. I saw on someone's handwritten notes, they wrote this part out and they did this, but they didn't get the answer right. I still gave them 2 out of 3 because they knew what rule they needed to apply. And I think that's what's more important. I don't care too much about the right answer. I care that you know how to do it. So just keep that in mind, okay? So don't stress out too much about it to the point where you're trying to use those programs to help you. I'm not even gonna say cheat. Like if they work correctly, then it works, but most of the time they don't. Is the grade on Canvas without the curve? Yes, Max, the grade on Canvas is your raw score. I need to plug that into my Excel spreadsheets and then calculate your curve based off of how much of the delta math you did, how much of the worksheet you did, and if you did both, what the bigger curve is going to be. So that will be done hopefully by the end of this week. Yeah, that should be done by the end of this week because I got to grade my stats class at some point. But yeah, that should be done by the end of this week. All right, so let's finish up this chapter. So the derivative of e to the x, like I said, right, is just e to the x. So what happens then if it's not base e? Because base e is such a special case that it equals to it. Well, what if it's another base? And that's what I want to give you right now. What if it was base, let's say 2 to the x, and I was asked to find the derivative of this? Well, the derivative of 2 to the x is almost the same as e to the x. It's almost the same. Derivative of 2 to the x is also 2 to the x, but it actually has a little bit that follows after it. It's 2 to the x times the natural log of 2. And this is going to be the case for any base that is an e. In fact, it even works for base e. You ready for this? If I took the derivative and I followed this rule for e to the x, right, is going to equal to e to the x times the natural log of e. For those of you who have practiced natural log in e, do you guys know what natural log of e is equal to? Anyone have any ideas? What is the natural log of e equal to? You can type it into your TI calculator, and that program will actually do that one correctly for you. The natural log of e is just 1. So what this is equal to then, if this is just equal to 1, this is just equal to e to the x. Whereas this one right here, natural log of 2 is not equal to 1. It's equal to some decimal. I would just leave it as the natural log of 2. So what I'm saying is, whatever base you have to the power of x, if you're taking the derivative of this with respect to x, this is always going to equal to whatever base you had to begin with to the power of x times the natural log of a, whatever your base is. And this is another one. This is one that's a little bit more difficult, but you do need to know. Okay? This is one that you do need to know. So keep that one in mind. You guys okay? Not okay? You are okay? Someone okay? That's the derivative for any base of an exponential function. So you have 5 to the x, derivative of 5 to the x, 5 to the x, ln of 5. Get that down somewhere. I guarantee you, I'm going to ask you, hey, what's the derivative? I'm going to say, here's y is equal to, let's say, 13x. And I ask you to find the derivative of this. You guys should be able to tell me, oh, y prime, that's just equal to 13x times ln of 13. And again, that's it. It's one of those things that you just kind of have to know, just like cosine, tangent, cosecant, inverse tangent, inverse cotangent, all those guys right there. If you just kind of know them, then that's pretty much it. You guys okay? I know I'm kind of just throwing you these derivative rules, and I really wish like I had a better way of explaining why that is the case, but I just I don't trust my skills in doing that. And it's something that if you are interested in, you should look further into it as to why that is the case. All right. All right. So that's another derivative that you need to know. So derivative of base A, right? That's one there to know. Just like if you had derivative of base E, that's one that you need to memorize, which is just e to the x itself. And let's move on. There's what if it's the base is log? Remember, log itself is a function, and that function of log is actually the inverse of an exponential function. If you don't know what I'm saying is this. If I had log base 10 of, let's say, 1,000, do you know why this is equal to 3? Because this log function, right, this log function is technically the inverse of your exponential function. I'm saying log base 10 of 1,000 is equal to 3 because the inverse is 10 to the third is equal to 1,000. Where this right here, this exponential function is the inverse of that log. And you're probably going, what the heck? So we don't really talk about log as your base because log itself is a function with a specific base, right? So whatever your specific base is, the inverse of that would go in the base of your log. Anyways, let me move on to that. Since we're actually talking about logs, there is a derivative here for the natural log of x. The derivative for the natural log of x, you ready for memorize this one? This one's just as difficult as the e to the x one. Actually, it's a little bit more difficult than the e to the x one. The derivative of the natural log of x is going to be equal to 1 over x. The derivative of the natural log of x is equal to 1 over x. So whatever's inside here goes down underneath. Let me do a problem for you, for example. Let's say I have here, I was asked to find y prime when y is equal to 4 times the natural log of x squared. You ready? So 4 is just a coefficient of the function natural log of x squared. That's just going to follow along for the ride. So when I do the derivative here, y prime, it's equal to 4. That just comes along for the ride. You ready for this? What's the derivative of ln of any stuff? It's that stuff that goes in the bottom. So it'll be 1 over x squared. But you got to chain rule this thing. What's the derivative of x squared? What's the derivative of x squared? That's 2x. So you see here, the natural log of x squared has an inside function just like earlier. Inside is x squared. The outside function is ln of that stuff. Well, what's the derivative of x squared? That's 2x. The derivative of ln is 1 over the stuff that's inside the ln. And what's the stuff that's inside the ln? It's x squared. So that would be your answer for that derivative of the natural log of x. You guys okay? Like I said, I feel a little bit bad for throwing this all at you, but it's just, I wonder if natural log is grass fed. No, David, no. Natural logs do decompose and end up feeding grass, if you want to look at it that way. Can you picture a log that isn't natural? Yeah, let's talk about log base anything else. So if I had, for example, natural log, by the way, is a special log. I don't, it's a log base E, right? That's all natural log is, by the way. So if I had, for example, instead of natural log, I instead had log base B, right? Let's use base A since we used A earlier. Log base A of x. If I was taking the derivative of this is actually equal to 1 over x, but 1 over x ln of A. This one is not as common, by the way. This one I've never really seen show up too often on a test, but it is something that if you have it memorized, it is an easy thing to do. So for example, if I had, if I was asked to take the derivative of, let's say, I don't know, log base 10 of x squared, right? If I was taking that derivative, that's going to be equal to 1 over x squared natural log of 10 times 2x. And that would be it. So a lot of stuff that just got thrown at you today. I know. But it's hopefully, I'm hoping you're seeing that it's not too difficult to do. They're just like additional rules, just like you would learn with like sine, cosine, and tangent, inverse cosine, inverse sine, and inverse tangent, and all those guys as well. Right? So that's pretty much it for chapter 3. Like I said, chapter 3 and chapter 2 used to be combined as one gigantic chapter. So you would have to do like, you have to learn the product rule, quotient rule, chain rule, right? All these power rules and all that stuff. And then once you learn that, then you also learn it to apply it to these special cases as well, with the chain rule and the inverse trig functions and the inverse of regular functions. So it got split up into 2 chapters. I think it's a little bit easier this way. So then you're still being tested on product rule, chain and quotient rule and power rule and coefficient rules, right? But now you're applying it to a little bit more difficult problems, okay? So just keep that in mind when you are going over these right here. So that's pretty much it for Unit 3. Let me show you your homework that is posted on here now. And then the Delta Math should be up by the end of today. And if not, it'll be up by the end of tomorrow. So what you can do before that is the homework so far. So here we go. So 3.4 part 1 was the derivative of inverse functions, right? That's that table stuff, and yeah, right? That's like, I think 6 or 7 problems. And then now I have 3.4 homework part 2 posted as well. So if you guys want to take a look, I put up a backup for it right here, but you still can do it on Cami. I just put the backup up just in case your or just in case Cami goes down again, because I don't know if you guys remember, I think there was a couple days where Cami just decided to not work anymore. Oh, do you not want to preview? I have to click on you instead? Yeah, I have to click on you instead. So you can click on it this way. So just in case Cami decides to not work, you can actually go in here as well. And I tried to title it what numbers you need to do. So for example, for this one, you only have to do numbers 1 through 42, but do multiples of 7. So you do number 1, number 7, 14, right? And so on and so forth. Oh, that's beautiful. 3 to the cotangent of x. That's a fun one. So go ahead and get those, get this done, right? 3.4 homework part 2, right? And then I have your 2 review this time. So this curve is going to be just like the last curve, except I have 2 of the book problems now. I have a worksheet and I have a book review. So those are going to go towards your curve. And then I'll put up the Delta Math later today. That's going to go towards your curve as well, right? So this is the review right here. Does that work? Yeah, that works. There we go. Are you going to load? There you go. So you can take a look and see here, right? Now, what I need you guys to do is to start working on this as soon as possible. On Thursday, I have no real notes to go over anymore, All right, we're pretty much done with this. So what I need you to do is start going through these problems and figuring out what you're struggling with, anywhere from 3.1 all the way up to 3.4, and then come in with questions, because we'll do some review. I'll have some questions, some ideas of what problems we can look at. And other than that, I won't have much else. I need you guys to help feel what you guys need. Can you show an example of how to do a problem like number 14 on the homework? Oh yeah, let's do that. That's actually a good way to start. Was that the cotangent one? Let me go open that up. Yes? Yeah. Let's do a problem like that. That wouldn't hurt. So let's do some more problems today, actually. Let's do some more problems today before I let you go. And you can get some experience here. So let's say I have here, I was asked to find, right, y prime when y is equal to, let's say, 5 to the tangent of x. Right? 5 to the tangent of x. So again, please note that this is a chain rule problem, right? The inside function is tangent of x. The outside function is 5 to the stuff, right? So let's take the derivative of this with respect to x. What's the derivative of tangent? Derivative of tangent is, I hope you guys know, is secant squared x, right? What's the derivative of 5 to the stuff? It's 5 to the stuff times the natural log of 5. So when I'm asked to find the derivative of this guy, I write down the derivative of the inside. The derivative of the inside is secant squared x. What's the derivative of the outside? The derivative of the outside is 5 of tangent of x times the natural log of 5. And that's it. It looks weird, I know. But that's all calculus is. It's just like these weird looking symbols, but they're right? As long as you applied the rules correctly. Did I apply the rule correctly? Derivative of a to the x is a to the x times ln of a. Looks like it. My a is 5 in this case, so it's 5 to the whatever stuff it was. In this case, it was tangent of x instead of just x, times the natural log of 5. And that would be it for that one right there. You know what? Here, try this one out, guys. Try this one out before you go. It is a good chance for you to practice a couple of these. So let me go ahead and open up this blank page right here. And you can try this before you leave today. So let me see what you get, and let's see if you guys are okay with it. Let's say I have here, I'm asked to find y prime when y is equal to 2e to the x plus x e to the 2x. You guys go ahead and try that before you leave for today. See what you guys get. Find the derivative of 2e to the x plus x e to the 2x. See what you guys get. I open up the pair deck onto a blank page for you guys so you guys can do that before you go. If you have already closed out of it, let me give you that link one more time before you go. Once you get your answer for it, I think that's it for today. Yeah, once you get your answer for it, that's going to be it for today. You got about 6 minutes to do this. Let's see what you guys got before you leave. Oh, there's 26 of you guys in there. And then after that, I think that's it for today. Start looking over the homework. Start looking over the review. Start looking at, if you haven't done so already, start looking at 3.1 all the way to now. Hopefully you've not done that and you've finished 3.1, but if not, it's due next week. Your test is next week on Tuesday. So we'll review on Thursday, we'll review on Monday, and you take your test on Thursday, or Tuesday next week. Tuesday next week, write this down somewhere. Test next week is going to be on December 8th. December 8th. All right. And I think that's it. Yeah, I think that's it. I'm just going to take a look and see what you guys have here for your answer, and then we're going to call it a day. I'm going to go ahead and end the recording for right now. And if you are watching this recording, hopefully you are attempting this problem and putting it into the pair deck. All right.